Come on in, Aaliyah. Take out your notebook, okay? All right, does everybody have their science notebook? I have to ask because somebody in my homeroom has been here for a week now and she has not yet brought this. I know we just started back on science yesterday, but you know how much table writing we did yesterday, right? And she hasn't done any of these preceding days of work. And what's our deadline for getting all our grades in for our progress report?
Friday?
No.
Wednesday.
No, it's today.
What?
And since this other kiddo that I'm talking about has not brought in her notebook yet, can she make any of her past assignments up? Nope. So her progress report is going to look terrible. She doesn't even have her notebook.
Progress reports are today?
Cut off is today. They get printed tomorrow.
So when do you get them?
I think tomorrow. So for my virtual friends, if you have not submitted any of your assignments in any of your classes, realize that that's going to affect your grade. I know several of my friends that do really well on submitting assignments. You haven't submitted everything. So we have to put in zeros. We can't leave E's on there. Well, a couple things I can leave E's on, but we can't have a bunch of E's there. So assignments need to be turned in today, okay? Because we have to put in assignments, especially before we leave today. On this big photo they want me to show you guys. Okay, first things first. Share screen, live image. Remember yesterday when we looked at the cups that had balloons in it? Come get another. So the balloons had been frozen, correct? And when water freezes, put it to the side, the one that's broken, and get another. When water freezes, it does what?
It turns into ice.
It turns into ice, yes. But what is the size of ice relative to the size of water?
Bigger.
It's bigger. Okay? So I kept having people say, pop the balloon, see what it does. Well, I did. And in my homeroom class, apparently most of my students can't see. So most of my students will end up on the floor over here, grouped together rather closely to see the screen. So Cody Smith was sitting right here, and I popped the balloon over the trash can. And I mean, I had the cup down in the trash can. And rather than it going down in the trash can like I had it intended to go, it sprayed diagonally out and sprayed Cody. All right, so we just said that ice is bigger than water, right? The solid form is bigger than the liquid. So I got rid of the balloon. Of course, the plaster had hardened around the balloon when it was frozen, right? So it left the hole behind. So think about that. In a cave, not a cave, but in rocks, like in the Grand Canyon, do you think water would freeze in the Grand Canyon at nighttime?
Yes.
Yes, because it gets cold at night. Well, the water would then melt the next day when the sun came out, right?
Yes.
And it would leave holes, wouldn't it?
Mm-hmm.
Sort of like that.
That's why there's all them holes.
That could be part of why we saw holes in those walls. Wouldn't necessarily leave holes that size because nobody's leaving massive balloons around there. But it would leave behind holes, wouldn't it?
Mm-hmm.
Because the ice expands, right?
chill.
Does. And the other thing is that rock on top, the plaster, is thin, so it would break after time, just from gravity pulling on it.
Did the plaster break on top?
A little bit of it broke, but see how it left behind the hole?
Yeah.
So ice can definitely cause holes and cracks in rock, can't it? You see all that? It can tunnel its way through. Water can drip down into rocks. Yes. Water can drip its way down in rocks, freeze, and create holes. And then the water disappears because it evaporates, right? Look at that. You wouldn't really see that much of a hole on top, but look how much of a hole there is down in it. It's like a cave, isn't it? Yeah, right. It makes a big cave on the inside, but from the top, you don't see much. Hold on, ladies. Let me get your temps. And the plants are continuing to try to germinate in the plaster. So I just wet the plaster because my friends are asking about that too. So not much germination so far. Thankfully, they weren't sprayed last night with Clorox, unlike my book that got sprayed. Okay, so this lesson is supposed to start with me showing you in your notebook, you're going to be on 23. You're not writing anything yet. Okay, so looking at this image, can my friends online see this image of rocks with holes? You got
I
to.
can't.
Can anybody see the picture of rocks with holes? You're going to have to unmute yourself so you can answer me. Can my friends online see the picture of rocks with holes?
Yes, ma'am.
Yes, ma'am.
Okay, all right. There you go. Okay, so guys, what do you think could have caused those holes in the rocks? Ice, maybe. What else could have caused it? Water.
Plants.
Plants, possible. Do you notice how those rocks look really, really smooth?
Yeah.
What could have smoothed them out?
Being squished.
Being squished, maybe. What else could have smoothed them out?
Us.
No, not us. You think somebody would stand on it for a million years?
No.
I'm not going
use
to.
that machine.
I like that. I heard that was Jordan, right? That said water. Have you ever noticed that on the beach, a lot of the rocks look really, really softened? They look really smooth. Doesn't that kind of remind you of that?
That's because of water pressure.
Water. It's water running over it. What is it, Kayla?
Like a sand dollar.
Like a sand dollar. That's an animal, actually.
What's a
And
sand dollar?
they're shaped that way. Well, I'll show you one another day. That does present a good observation. This picture, do you see how it looks taller in the middle and narrower at the edges? That is similar to a sand dollar in that it's taller here and narrower here. Again, what would cause that specific shape?
Water.
Water. Why would water do that? What would the rock be doing in the water that would make it smooth?
It could have
Flipping,
been,
maybe.
it could have been like getting knocked over every time there's waves.
It could have been getting knocked over and the water could be smoothing it, right?
Yeah.
Because we saw yesterday that just little old water, it can break things down, can't it? So you guys see those holes? Do you see how some of the holes are really smooth? Some of the holes are, like this one is jagged. Why do you think the holes are different? Why is that one jagged and this one right here is perfectly smooth? Maybe they have different causes. Aaliyah, what do you think caused that really rough looking hole? This one right here, Aaliyah. What does that remind you of that we looked at yesterday under the Elmo? I can't hear because there's somebody in my ear right here. A big a wave. That doesn't look like water to me. Does anybody else think it could have been something different?
Yeah.
What do you think?
Maybe like an animal squished it?
I'm not thinking an animal squished it. We didn't look at anything from an animal yesterday. Thinking about what we looked at yesterday. So Bryson wasn't in here yesterday. I want somebody to say this based on what we looked at yesterday in class. Michaela.
Maybe the air made it crash under some other rocks.
Maybe. But what else did we look at? We looked at 4 different causes. What?
Plants.
Plants. It made irregular holes, didn't it? In the plaster. The plants made irregular holes, didn't they? So what do you think made those really smooth holes?
Over there, by the window.
In the window. It's far away from the bleach that gets sprayed every night.
Are they growing? Ice.
Ice or
Plants.
ice or water. Ice or water going through. So do you think maybe water dripping in the same spot over time could do that?
Yeah.
Isn't that crazy to think that just a single water drop hitting the same spot over time can happen?
Miss Van Diver,
Yes.
all I see is the balloon.
Balloon. Let me hit stop share. Whoop. Image mate. All right, now do you see rocks with holes photograph?
Yes, ma'am.
Okay, so this is what we're talking about right here. These smooth holes we think might have been caused by water, like water dripping in the same spot over many years, many years. And this irregular hole, if you remember looking at the pictures of the plants in the plaster, they made those irregular holes in the plaster, right? So this is reminiscent of a plant, what a plant could do. Okay. And Kayla pointed out this kind of looks like a sand dollar. Look how the middle is taller and the edges are skinnier. Anybody notice that? Let me leave it on that photo for a minute. Let me see if I can find a sand dollar to compare it to. I have a big old sand dollar in this room. I just gotta remember which location it's in. Sand dollars aren't plants, they're animals.
I didn't even know that.
Sand dollars are not plants. I just did
I
that.
know they
So, can someone go turn off the light and see if we can manipulate the lighting in here? Aaliyah, you're closest to the switch. Can you go turn off the light, please? That's the sand dollar from the underside. Go turn off the light. There you go. Nope, off. There you go. Thank you. It's not coming up. There we go. And that didn't help any. All right, turn it back on. Turn on the other light though, Aaliyah.
They're dark, but not too dark.
Thank you. Okay. Did you see the lines in it there for a minute? You see the lines? Okay, so right here, it's sealed up, but that's where the sand dollar's little feet would be. Okay? This is called an oral disc. That's where its mouth is. Now, what plant do you know that has an oral disc to eat stuff and has feet? That's not a plant. Plants don't have oral discs and feet. Plants don't move themselves to get to their food either. And that's an animal. Yes, ma'am.
Starfish.
That's an animal.
I know, but I thought that was one that
It has those. But again, it's another animal. That's how I know it's an animal. Okay, this is an animal, guys. Here's the top of it. And again, it's being weird because it's over contrasting it. Let me see if I can shadow it. Can you see it? Can you see the lines, guys? No, it's been dead for a long time. Can you see the lines, my friends online?
Yes, ma'am.
Okay. So
Ma'am.
I don't know if you can tell, but the top of this is taller in the center than the edges. The edges are flattened out, which, as Kayla pointed out, that's like this rock, isn't it? That is designed, the sand dollar is designed to not flap around, to move around in the water easier. This thing here has been in the water for a long time. It looks like it. Look at the holes in it. And the way it's smoothed down on the edges. So is this sand dollar. Right? It's just that this is inanimate. That's a rock. This is not a rock. This is an animal. Okay. This happens to be a really good specimen of it. It's only got one little chip to it. Okay. And you can hear the little feet that are broken off inside it. Very good observation. I bet nobody else makes that observation today. And nobody made that observation last year either. Okay, so dripping water. Can you imagine for a minute if water were to drip through the ceiling for years on these desks? It would make holes like that right through the desk.
it would get soggy.
It would get soggy. It would go into, it looked like cardboard over a while. But it could make holes right through the floor. The power of water, guys, is amazing. It knocked holes right through that rock.
This is a tiny
It would knock holes through concrete.
This is a tiny drop. No wonder.
You know how they cut through granite? With water. They use water to cut through granite. Who has granite countertops at home?
Oh, granite.
Nobody else has granite at home? Nobody? Extremely hard rock. Beautiful. They use water to cut it.
Because the water hurt us?
Okay.
Is the water cutting us?
Okay.
Dropping for millions of years.
All right, let's get on with the lesson, okay, guys? Okay. One of the things that was proposed in here was that maybe someone drilled holes in this. But does that picture really look like someone could have drilled those holes and had it that perfectly smooth? No. Has anybody ever seen someone try to drill a hole in rock?
Yes.
It looks really messy and it fractures the rock. Have you ever seen someone try that? It looks messy. And generally it like chips up the rock. Craig drilled all those, my husband, put all those hooks on the wall. And when he did, it chipped up the cinder block a little bit. That's concrete. When he was putting those in, it chipped it a little bit, but it didn't matter because then he put the hooks on top of it so you don't see it. But when you drill, even with a special kind of drill bit, it chips the rock. That's what it does. That's not chipped. Those are perfectly round. Other than that one that looks like a plant grew in, because you can even see where the vine was if you look closely enough on that one.
I tried to do it before.
Not very easy. See, look right here. It looks like that might even be where a vine grew on it, doesn't it?
Yeah.
Sorry, it's hard to do this when it's so tiny. See, it looks like a vine grew in it for a long time. Up here looks the same way. Looks like a vine grew. right? No, that'd be rock. It's rock, just plain rock. Okay. What with this picture, thinking about what we did yesterday, what makes you think that's water or plants? Thinking about what we saw yesterday. What did the plant look like in the plaster?
It was all crushed up. It was all crumbled up like it was pushing the rock.
It did. It crumbled it, and it also had irregular lines around it, didn't it? What about the water? Did it make smooth holes in the sugar before it melted it?
Yeah.
It did. So what we saw yesterday was like a small version of what goes on at the Grand Canyon in a big version, right? Okay. So today what we're doing is looking at what we did yesterday and analyzing things. And I know it seems like we did all that yesterday in the chart, but we're going to look at it more and understand more what we actually saw. We're going to in a little bit. We're going to. All right. So this next part we were supposed to do in pairs. Kind of hard to do, isn't it? With your desks like they are, COVID precautions, a little hard to do these in pairs.
Okay, we'll tell you.
So we end up doing this whole group.
What?
So here's the first question. What changes, and this goes for my online friends too, so you probably need to take yourself off mute, okay? What changes did you observe when the materials at each station interacted? The first question. Let's look, I'm going to put, actually I'm going to put it right here. My friends online need to see. What materials were at one of the stations? Plant with what? Plaster. Okay. Next one was what? Water and sugar cube. Hold on, I'm not that fast. Ice. Plus plaster. All right. So what changes do we see, guys? Do we see any patterns? Go back in your chart to me. Look at your chart. It's several pages long. The plaster represented rock in the two labs where we did the plaster represented rock, right? Did the other thing affect the plaster in those two labs? The plant didn't affect the plaster?
Well, yes, it did, yes.
Did the ice affect the plaster?
Yes.
Need that for a reminder? It definitely affects the plaster, right? Okay. Did the air affect the shaving cream?
Yes.
Did the water affect the sugar cube?
Of course.
So in every single lab, the thing that represented the force affected the thing representing the rock. Because the plaster represented rock, right? Shaving cream represented rock, correct? Sugar cube represented rock, correct? So in every single lab, whatever thing we were using to represent force, plant, water, ice, air, those things all caused a change to the thing representing rock, correct? So is that a pattern?
Yes.
Absolutely. Okay, so look at the top of page 23 in your lab book. Top of page 23. So you're going to write a statement that somehow puts in words what we just said, that each one of the items that represented the force, that'd be an air, water, ice, and plants, caused a change in the thing that represented rock. Does that make sense? Each one of the things that represented force, I'm going to put this in parentheses, air, water, ice, plant, caused a change, and triangle means change, okay? To the thing representing rock. Just doing that weird thing again with the contrast. Each one of the things that represented force, air, water, ice, plant, caused a change to the thing representing rock. And remember, triangle just means change. I'm going to write that right here. That's for you guys. You don't have to write that on your page. That's just if you choose to write the triangle, I want you to know what your triangle means, okay? Here's another pattern that's noted in the book. It says, in all the stations, one material pushed on another and broke it up. Did y'all notice that? Okay. It did, didn't it? So in all stations, the one material broke up the, and I'm going to put rock in quotation marks because we weren't breaking up this kind of rock yesterday, were we? Yeah. We were breaking up shaving cream and plaster and what was the other thing we broke? Sugar cube, yes, thank you. Okay, in all stations, the one material broke up the rock. I'm sorry, it's coming in weird with the contrast still. Yes. Oh, look, now I'm getting better contrast. Oop, that blocks out too much. On the top one. My friends online, remember I need pictures of all your work today because I have to put in all your grades by this afternoon, okay? Whoever does printing in the office is printing them this evening or tomorrow morning at 7 or something, I don't know, early. And that's all grades in science and social studies. And just giving you a heads up, normally in health,
I give cooperation grades. You're not here, so as long as you've participated in some of my stuff, you're going to get a health cooperation grade, okay? I know we haven't done anything in health, but
Okay.
I'm just making it easy on myself and you, okay?
Okay.
Okay.
That's what 5th grade and 3rd grade's doing too. You don't have to specify first station. It just says, in all stations, the one material broke up the rock. Don't worry about that. Just this right here, because we're just stating overall. What? Stations, comma. No, copy that. Okay, if you copy it, you're great. We're about to go on to the next statement. Breathe. As well as you can to this mask. It's so annoying. All right, then, just so you guys read it. All right. Okay, for that second question, it says, what did you notice when the interactions changed? Like when I blew harder versus blowing softly on the shaving cream. What happened when I blew harder?
It flew on the ground.
It flew out farther, didn't it? So if it's a stronger wind, it causes more change, right? What about when I put more water on the sugar cube? What happened? It made the whole lot faster, right? What about when there was more ice inside the plaster? You need a reminder.
It made giant holes.
It made a bigger hole, didn't it? Right. I mean, that's a big balloon versus a small balloon, right? And the balloon had the ice in it, correct? Okay. Hard plaster. Plaster rock. Okay. See that? So when more ice was pushed on the plaster, there was more force pushed on the plaster, right? More force meant more cracking, more breaking. Okay? More force caused bigger and faster changes. Does that make sense? So when I blew harder on the shaving cream, it caused the shaving cream to move more, didn't it? When I put more water on the sugar cube, it caused the sugar cube to make bigger holes and in fact just dissolve, correct? I need to get the clean.
We need a lake from the school and then let it drop it.
Yeah, no, we had that last year.
You mean what last year? A lake from the school.
Okay. Plant. All right. They're just starting to pop up, but you can see that they've caused a lot of change to the plaster, right?
Yes, ma'am.
It does. So yesterday, there wasn't as much change to the plaster. Today, the plants are a little bit bigger, so there's more change. Make sense? They do. Okay, so here's another one. Only 2 of them have germinated so far. This one and this one. This one's trying to. So they've broken. Remember, this is the piece that stuck to plaster. That's why it's broken. But this hasn't broken the plaster as much as the other one. They're breaking the plaster. Okay, so
Is there water in the plants?
yes, I'm adding water every day. I'm adding water every day. The more force, more ice, more air, more water, bigger plants, the more holes and cracks yes in the rock. And again, it's gonna be rocks in quotation marks because we didn't actually work with rocks yesterday, did we? I'm not liking this contrast in this thing. There we go. That's a little better, isn't it? More force, i.e. more ice, which meant my water balloons were larger, so there was more ice in them. More air, more water, or bigger plant, the more holes and cracks in the rocks. Jackson, we're on page 23 in your lab notebook, your logbook. You need to copy these as quickly as you can because you came in about 40 minutes late, okay? And I don't know where Jackson went because he was here for a moment and then gone. Okay, everybody have this?
No, ma'am.
Not yet? Oh, to my friends that are virtual right now. Okay, all right. To my friends that are virtual, my students, after we came back from enrichment yesterday, we did page 22, which was drawing conclusions based on what we learned in yesterday's lab. So when you submit all of yesterday's pages, if you could go ahead and do page 22 also, okay?
Okay.
Ooh. All right, so the third question on page 23, each student is going to do on their own. I've given you the answers to the first and second question. So based on what we discussed yesterday and based on what we just discussed, write your explanation to tell me what causes rock to break and use evidence from the lab. Okay, pull evidence from the lab. Say, based on what we saw when we did this with the water, based on what we saw when we did this with the ice, I know that this and this cause rock to break. Does that make sense? Okay, answer that third question. I know, it makes it hard. I don't know what to tell you. That's why it's really hard. That's why we're doing this. I can't go back and reteach the lesson. That third question says, write an explanation to describe what causes rock to break. Use evidence, which means pull stuff from your charts, pull stuff from there to tell me how you know those things break rock. Okay? You can put rock or, yeah. Or you can just say rock because what we did yesterday is a small scale of the big scale what goes on in the Grand Canyon. Okay. Right, I'm gonna give you guys 3 more minutes to finish your statement. Okay, that's more than enough time for some people. And I'll be just in the right amount of time for others, okay? And Bryson, well, I know you weren't here yesterday. We discussed all this in the first 2 answers. You didn't get something out of that too.
Welcome. Say hello to old Bender. Put those up right now.
Thank you. Just wait.
Be quiet, Taylor. Sit down.
Don't worry about packing permission. Okay, 1 more minute, my friend. Okay.
Okay, you're gonna draw it. Okay, what you hear. Okay.
Ellie, are you finished?
What did you use to see the rainbow? You use your.
Lee, I know you're cold. Try to bring a jacket or sweater to school. Huh? My room is one extreme or the other, cold or hot. And sometimes it's both in one day. Right now it's cold. I came here this morning and it was very hot. All right, so we're going to kind of discuss this a little bit. So if you haven't finished this yet, or you need to add your answer, maybe this will help you so you can have a better complete answer. Can water break rock? We saw a picture first thing this morning how it looked like water could break rock, right? Water can dissolve rock. All right. Who has ever gone in a cave? Who's ever gone what they call spelunking through a cave? Toward a cave? Really? Not very many of us, huh? 1, 2, 3, 4, 5 of us. Okay. All those things that hang from the ceiling, stalactites, that's from water dripping down with minerals in it. Okay. The water actually dissolves the rock, and that dissolved rock mineral is what keeps dripping down and adding to the thing hanging from the ceiling. That's dissolved rock.
Does it count as
Coming down.
Georgia way down in the ground?
No, not it. Can plants break through rock?
Yeah.
Okay.
Eli,
Can ice break through rock? Okay. Can wind break through rock? Absolutely. So those are 4 things that can cause rock to break. All right. The other part you needed to say was something based on yesterday's lab. We're not drawing right now because we'll get back to the lesson. Okay. So you also needed to back it up with something to do with yesterday's lab. Okay. So all those things, put away the colored pencils. For now, you're going to use them in a minute if you want to. All those things that break up rock, wind, plants, water, and ice, process of breaking up rock is called weathering. Isn't ice, isn't that part of weather? Isn't water, isn't that part of weather? I know plants aren't part of weather, but isn't wind part of weather? Okay, so I saw this on Pinterest and thought this would be a perfect drawing, even though it doesn't even go with our lesson. Officially, it doesn't go with it. I'm only supposed to have official PhD stuff. This I thought was a perfect picture. Weathering, erosion, deposition. Weather, because 3 of the 4 causes, water, wind, ice, those are weather related, aren't they? Because things get cold, that's weather. How you get ice. Waterfalls in the sky. Ice is snow, right? And then wind, that's obviously weather. It's not something out there blowing on the Grand Canyon. That's the weather. Okay, so 3 of those 4 causes are from weathering, are from weather. Plants are the 4th. So weather plus rock, weather plus plants breaks down rocks. Weathering is breaking down rocks. That's what it is. This is a picture of weathering. Ready? Yeah. It's taking it down. That's something different. We're going to talk about erosion Thursday. But weathering itself is breaking it down. So do we go through it? Weather our shirt sheet? Do we weather our plastic? We broke it down, right? We broke down the shirt sheet too, right? We did extreme weather. With melted, right? Got sticky all over my hands. Had weathered shirt sheet all over my hands. Did I weather the shaving cream in that video? It was all over my floor, right? So weathering is breaking down rocks. Make sense? Okay. Next thing you're going to do is draw a model that shows how weathering might have caused the holes and cracks in the rock. Essentially, draw a picture of weathering. You can use your pencil or you can use pencil. Draw a picture of weathering. Guys, you can use what I have. But let me show you what the part is weathering. Weathering is breaking. Weathering is not moving stuff away. Weathering is only breaking. Got it? It's not moving. That's not weathering. This is weathering. Okay? This is weathering. So, say I have a blue rock. One color. Rock.
Go down and down.
Right.
And
What can I do to cause that break? Water. What else did I do? Ice. So, I'm going to do this to represent. What else to do it? Okay.
What is this right here?
Okay. That's a really simple model, isn't it? And then I would need to label it. Plant. Rock. Wonder to be the symbol vote for it. Rainfall.
Get off the hoverboard.
Leaf.
Barely
And small.
You were right at
Rock.
Where's the rock related?
Well, I can't imagine. We're talking about weathering the rocks. Why would I have a big rock in the picture? Now, your prompt says related to Deer Creek Falls. So you could do it related to the waterfall. So you could show a waterfall. You can do that. I'm loading you guys with a lot of your answers. You can do parts of it. You cannot do a drawing that fast. We're on page 24. Page 24. I'm going to bring the poster over that I just showed the students because I don't know that you guys can see the poster, but I have a poster of weathering. Okay, so let me bring it over and show the computer.
I will throw that hoverboard out the window.
Clearly not everybody does. So here's a poster that shows weathering and erosion. Weathering itself is just breaking down rocks. Weathering, 3 of the 4 causes have to do with weather because it's water, ice, wind. Those are all related to weather. And the 4th cause of breaking down rocks is plants. But the other 3 causes, water, that can be in the form of rain. Ice, that could be sleet, or that could just be it gets cold. And so the water that's already around freezes. And of course, wind, that's weather, definitely. So weathering is weather or plants breaks down rocks. Okay? So your page 24 wants you to draw a model, which means draw either with your pencil or colored pencils a picture that shows how weathering might have caused the holes and cracks in the rock around Deer Creek Falls and label what's going on in your picture. So I know what's the hole in the rock, the broken rocks, the big rock, and the 4 causes of the holes.
How do you spell Deering? How do you spell Deering? Like his like I said, like what do y'all do during recess?
D-U-R-I-N-G.
Yes. There are 4 causes of weathering.
Oh, her feathers. It's a dog. Feathers. Feather. 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 Taylor, stop. Wonder. Taylor, sometimes when you poop. Taylor, it looks either one. Taylor. Well,
They're not supposed to be women. So.
I see.
Okay. Weathering, water, ice, wind, plants.
My baby girl.
Really causing the whole the Grand Canyon, not on the generic mountain.
Come on, Caleb, she's back on. Get over here and say
Okay, so my virtual friends, you're drawing a picture that shows the four causes of weathering and how they cause the holes and rocks around Deer Creek Falls. And that's that picture of the waterfalls with the moss on it. And then label your picture so I know what's a plant, what's water hitting it, all that. Bless you, by the way. And then at the bottom, you can explain your picture so I know what's going on. Okay. Right, row. Drop the pencil. I'm gonna add a little bit to make it for what you guys draw. Okay.
1, 2, 3, 4. 1, 2, 3, 4. I don't want to put the board. 1, 2, 3, 4. 1, 2, 3, 4. Silly. Yes, ma'am.
All right. My online friends, I'm going to show you the picture again, okay?
Okay.
Oh, wrong one.
Yeah.
Okay, can you guys see what it says, lesson 7?
Yes, ma'am.
Yes, ma'am.
Okay, now if it would go to the next slide, it would be wonderful. It was working this morning. Now it doesn't want to, because you know, it can be that way. Bless you. There's Deer Creek Falls. That's Deer Creek Falls. All right, you guys have an assignment. I'm doing mine right now.
Y'all did it. One of that fixed it. Turn it this way.
Stop.
There, now sit on it. What was this? What was this? I don't know what Christmas is like right now. I'm tired.
It just needs to explain weathering.
You got sit. You can sit. Hey, look it up. Caleb, stop. What? All over. No. Get off my leg.
All right, have my online friends done their weathering model on page 24?
Yes, ma'am.
Okay.
Yes,
And
ma'am.
make sure you have it labeled so I can see your 4 causes labeled: plants, ice, water, and wind, okay?
Okay.
And then label your rock. I do, over there. Gray, you can use a pencil. Jordan, for gray, you can use a pencil. The pencil's gray. Yes, Aaliyah.
Meow. Meow.
No, maybe not. I don't know. Nope. Nope. Water. This is what we have at our house for bottles. And I've got 2 boys. So remember to label your drawing. Show me that rock has broken. Show me where there are holes or cracks, whatever you are trying to show me, and explain it in words. That's what you have those lines underneath it, Logan. There are lines at the bottom of page 24 to explain it in words. All right. I'm going to give everybody 4 more minutes till 9:20. Okay? Then I'm going to show you what the book has. What the book has is remarkably similar to the thing I got from Pinterest. I looked at that and I showed my husband. I said, wow, I wasn't so far off pulling that image from Pinterest. The whole time I was doing it, Colby was saying, are we ready to go? You ready to go? You ready to go? Hey, Mom, you ready to go? Got it. He was trying to be funny. He's got my sense of humor.
That's how I started. You're like, stop. Always
All right.
back in the back.
3 more minutes, guys. If there are any pages that you're missing, like yesterday's Bryson, I would be getting somebody else. Like Logan, who's just sitting there not using his book right now. He's begging Logan to use his book. We got 3 minutes to be copying yesterday's work. You might want to get yesterday's work from Logan right now. You got 3 minutes. Just your grade, not his, it's yours. You got a lot of copies.
Do we have to put color on the water?
Have it labeled. You got a lot of copies. You want 5 pages? Now you understand how we're gonna get through to page 38. They only put a few words on
It's not that
each
much,
page.
actually. Math.
You did it a few days ago. Okay, do it later on. All right, so we have 2 more minutes. Let's don't make a lot of noise right now. Whose were you looking at to get it to? All right, are you finished with your drawing yet? Okay, get it labeled so you. MAKING.
Put those up. Hey, pay attention to her, not the motorcycle. Put it down. You pay attention to her, not the motorcycle.
It's hard. All right, 1 more minute, friends. Maya, I'm afraid you're going to drop them that way. When you're done with this, put away your colored pencils because you're not going to need them again. Okay.
Idiot.
Miss Bolton's going to come get y'all.
No.
It will depend because she's having to kind of, I know, but she's having to amend her schedule with discoveries this week. All right, Zoom friends, I'm going to put you guys on a different screen share. Image make screen share. And let me get straight. All right, so here's the image that the book had. It showed a hill. It shows these little plants. They look like little dragonflies, don't they? And then it shows the roots breaking up the rock. You see that? And it shows little holes. And here it shows the waterfall coming down. And it explains with words, falling water puts force on the rock. Please stop moving the desk all around. Okay, let's do that again. Falling water puts force on the rock. Plant roots push on the rock. And so the rock breaks up in smaller pieces. Can we stop moving our desks all around?
Caleb?
Logan. Yes, not drawing. Right? So, what forces does it show in the picture causing weathering? Water and plants. And it actually explains it, doesn't it? So if anybody wants to go back and add any words to their picture, if that helps you any, go ahead. If not. All right, so what I added to the anchor chart, weathering is a natural process that breaks rock into smaller pieces, and natural materials, actually movements, including moving water, ice, wind, and plants cause weathering. Okay, so weathering, 3 of those 4 causes come from what?
Weather.
Weather. So it's in the word, isn't it? Weathering comes from weather plus plants, right? Okay. Yeah, weather plus plants. All right, so what causes rocks to break? That's been our phenomenon question. Logan. What causes rocks to break? Rock to break. Tell me one thing, Michaela.
Water.
Water, moving water. What's another thing that causes rocks to break? Aaliyah. Plants. Okay. What else? Ricardo. The wind, right? Okay. Now, one of my online friends, virtual friends, what's the fourth thing that causes weathering? We've got wind, plants, and water. What's the fourth thing that causes weathering? Melanie, Kimber, or Joanna, what's the fourth thing that causes weathering?
Wind.
We have wind. What's the other thing?
Water.
We have water.
Sign?
We have plants. What's that last thing?
Ice.
Ice. There we go. Very good. Okay. So some of you guys, I don't remember if it was this class or another class, had said in the beginning of yesterday's lesson, they thought that maybe people walking at the waterfall had caused the holes and cracks. Do you still think people walking there caused the holes and cracks?
No.
Do you think animals climbing there caused the holes and cracks?
No.
So what do you think caused the holes and cracks at Deer Creek Falls? Those four things, right? There you go. Those four things are the things that cause all those holes. Okay. Plants, someone pointed out plants are pretty flimsy, but flimsy and gentle they might be, but they're strong enough to break rocks, right?
Oh, yeah.
So stronger than people in some ways. Tomorrow we're going to start learning about another process. Today was weathering, which is breaking up rock. Big rock into little rock. Okay, that's weathering. Tomorrow we start learning about erosion, which is something different. Okay, so that's actually the end of our lesson. Bryson and Kayla, I know you guys both need to do catch-up work, so Kayla work with Jordan to get stuff caught up, and Bryson work with Logan to get your stuff caught up. And my online friends, just give me pictures of your work that you did today. Okay.
Can we do it off the camera?
What's that?
Can we do it off the camera?
You're cutting out really bad. My speakers are messed up. Can you use the chat feature to message me?
Okay.
Okay, thank you.
I washed my hair today.
All right, Melanie or Kimber, do either one of you guys have questions?
No, ma'am.
Okay, make sure you get me your work by this afternoon, okay? Because I have to put in grades by 3 o'clock today, okay? Take pictures and you can either text it to me or send it to me via Class Dojo private message, all right?
Where'd it go?
That would be of pages 23 and 24 for today's lesson, okay? And don't forget to go back and do 22 yesterday. How did the interaction of one material with another during this investigation help you understand the effects materials might have on rocks? I'm going to put that up on the projector so you can see how we did this yesterday, because you guys didn't get this part yesterday. So this is how we set it up in class yesterday. Water created holes in sugar, maybe water could, and you could tell me what water could do to rock. Ice cracked the plaster, maybe ice could, and tell me what ice could do to rock. Plants broke holes and made cracks in plaster, maybe plants could, and tell me what plants could do to rock. Okay, so if you guys want to copy what I have there, and then those sentence starters, finish out the sentence starters too. Does that make sense? That's page 22, that conclusion part. Okay. Okay, so my friends who aren't having to make up work, if you need to read, you can draw. We have almost 20 minutes to go to enrichment. My friends online are having to get a part that y'all got done in parts of the outside yesterday. Walrus would be a lot fatter though. They weigh about a ton. All right, I've got several people trying to work, and with a lot of talking, it makes it hard. So be quiet, okay? Get one piece, please. Just one piece, please.
In that area. Okay.
Okay, so have my online friends copied all this yet?
No, ma'am.
Okay,
Yes, ma'am.
all right. Once you copy this, you're done with me for the day, so you can sign off, okay? And send me the pictures of your work, okay? Page yesterday's work and then today's work too, okay? Nobody ever finished my maps from last week because I was hoping to put some maps up there.
Last week. Oh, I did. I didn't know we were I'm pretty sure I have to. Whoa, that was awesome. Copy that.
Getting there.
That's new. That's what I do.
Did you copy all of yesterday's work into your book? Remember how you wrote it on notebook paper and then you were supposed to copy it in? Do the copying in. Guys, if you could leave your notebooks open to page 24, I'm going to walk around and grade your model that you drew, okay? That's fine, that's fine. All right, my friend is talking about Lolo, talking on help. Transfer. It will be hot if I turn it up very much. I'm worried that. We'll get cumulative effects. Black parts on the inside. It's just glass on the outside and the black parts on the inside. That's the preferred board. When they get wet on the inside, it's going to stuck. Okay, Joanna, have you finished copying it all?
Yes, ma'am.
Okay, Kimber, have you finished copying it all? Okay, I'm gonna go ahead and end the meet then, okay? Oh,
Okay,
wow.
bye.
I gotta check the chats, because boy, there's a whole bunch.
Bye.
All right, bye.
Bye.
They were. Hold on, please. Yes. All right, stop share. And